Hi guys, welcome back to the channel. In this video we are going to discuss about priority encoder. So in the previous video we have already discussed the basics of encoders and a brief on priority encoder, but in this video we are going to discuss in detail the priority encoder. So let's get started. So if you observe this is known as the 4x2 encoder. So we already know the encoder because 2 power n inputs and the n outputs it would contain. So it is from D0 to D3 inputs and AB outputs. So that is 4x2, that is a normal encoder. So in the normal encoder we can pass the variables and we can get the output in the binary format. So that is not a big deal. But where the problem arises is in the if you pass in 4x2 encoder, if you pass all the inputs as 0, so it is unable to select a line, because in the normal encoder if you have to pass in one of the input line and it will be output would be produced according to the binary format. So that is the thing that we know. But here all are zeros. It is every input selects only the a, that is 0 0. So that is the main drawback in the first situation. And the second case is if you pass multiple inputs at a time. So this is also a huge drawback in the normal encoder. So for this purpose only we are going to use the special one, that is priority encoder. So let's see that what is meant by that. So in the previous video, encoders video only, we have discussed in brief. So if you observe there, that is 4x2 encoder, priority encoder, not normal encoder, priority encoder. Here we have the as normal encoder we have 4 inputs and 2 outputs. Along with that we have another line called the V. V means value or a valid one, valid output. So if you consider in the normal decoders, in the decoders we will be having some line called enable line. So that we also saw the uses of that enable line. So in this priority encoder we have line called valid line. This makes the priority encoder very much useful or understand much further. And the truth table we will see now, but before truth table we should know the order of the priority. So D3, D2, D1, D0. So this is the increasing order of the priority that you can see over there. So let's quickly see the truth table. So as D3 is dominated by all the things, if any of the input contains D1 or D3, so D3 will be dominated. So before all D3 elements would be considered as don't cares, because whatever may be the terms, it might be 1, it might be 0, so it might be 1 also, but it will not select because D3 is already there. So D3 as it is highest, so D3 will be the our final output. According to D3 means what? 1 1 3. So output would be AB would be 1 1. So that says the priority encoder. If you consider that as the next one, suppose if you consider that D2 or D2 D1 is high, suppose consider, so D2 and D1 high means the D2 will be our output, D2 output AB will be produced at the output side, that is 1 0. And the valid input also indicated there, means that if valid is 0, so any input it doesn't care, but output also don't cares. Means a simple thing, it will not work, I can simply say. If valid is 1 only, it will work like enable line in the decoders. Then only the output would be produced as seen there. When the V is 1, all AB output is producing. When V is 0, output is don't care terms. So this is the unofficial, the third output we can simply say. So for that also we are going to have the output expression, and for that also we are going to have the circuit diagram. So let's see for the first the V only. So V is generally nothing but all, if any of the input is 1, the output will definitely 1. So according to that we will have the output expression for V is D0 plus D1 plus D2 plus D3, because when V is equals to 1 only the circuit will work, otherwise it will not work. So for that logic also all 1s should be present in the all over the circuit, all over the truth table. So the min terms would be all, so we need to sum all the elements in that. We need have, means all the elements inputs we need to add to get the V. Then in the truth table we have another 2 variables, that is A and B. So for the A also, if you consider last 2 min terms we had, I have highlighted in the box also. For the A we need to have the output expression. So if you consider the A, so the first one position in the M2 position, so for that you can observe there, that is the single one, that is in the D3, corresponding D3. So simply write D3. So the next one in the M2, that is min term 2 position, that is we need to write D2 D3 bar. In that format we need to write, and we need to have dot product. So that is the output I have written there. So this is in this format only we should write the output expression for the A. So as it is the priority encoder, we should write in this representation only. We should not write like a normal encoders. Normal encoders, we just write corresponding one. Means suppose if A is there in the position of M2, we should just write D2. That's it. But here we should not write like that. We should consider all before terms. Zeros also we should consider with the help of bars. So finally we have the expression of A, that is D3 plus D3 bar plus D2. So here I want to going to say some trick. So remember this trick. So this trick is very important for the conversion of 8x3 priority encoder. So in that we are going to have much more complex Boolean algebra. So for seeing that, we need to have a small logic here, that is distributive law. Means if something output expression is like there, that is x plus x bar into y, so we can represent that as x plus x bar plus x into y, x plus y, like that we can represent. So according to that, I have already discussed that Boolean algebra. So you can, if you want, I am giving the video in the description box, check it out. But here we are going to use the distributive law. So if you consider that d3 can be split like that, means the addition can be, multiplication can be distributed like that, d3 plus d3 bar plus d3 plus d2, we can split like that. So we already know d3 plus d3 bar is 1, so output of A is d3 plus d2. So in the same format, we are also going to have the output expression for B. So if you consider, we have two minterms in the M1 position and M3 position. So M1 position, if you consider, that is the D3 bar and D2 bar, and the finally D1, the one also we need to consider. So if you consider in the M4 position, that is the corresponding to D3. So both we need to add. After adding that, if you can see in the same format we have written there. So D3 plus D3 bar X. So if you encounter this kind of formats, just remove the D3 bar in the second terms and write the as is, that is our final output expression, you can say. So if you consider in the first term, that is D3, in the second term we have D3 bar, so we need to remove the D3 bar, and that is our final output expression. I can simply say that is the trick that you can remember. So as we all got the output expressions, so we know there are total 4 inputs and 2 outputs in the 4x2 priority encoder. So we need to draw the circuit diagram from the output expressions. So we had A, we had B, we have V. So according to that, we need, just merge or join the variables with the OR gates, and you know how to draw that. Suppose if you take V, we have D0 plus D1 plus D2 plus D3. Just join all the variable lines with the OR gate. That becomes our final output V. So if you want A, just connect D3 plus D2, the variable lines with the OR gate, that is the final output. So if you want B, so D3, so D3 is simple. So D2 bar, so we can take a NOT gate there, and D1 a AND gate, and we can join with the OR gate. So that becomes our final output B. So I hope you understood this 4x2 priority encoder. Now let's start the understanding of 8x3 encoder. So in the 8x3 encoder, we have 8 inputs and 3 outputs, if you see there. So we have already discussed in the in the previous video, but we also please once again refer to that concept. So if you observe, this is the truth table for the 8x3 encoder. So if you observe clearly that we are going from D0 to D7 ABC. So in this, if you have selected A, means the first one, the D0, so it will be directly selected 0 0 0, that is D0. But in case that if you also have one in the position of D7, then which one will you select? What is the output would be ABC, whether it will be 0 0 0 or it will be 1 1 1, which one will be our output? So this decides based on the priority. So that priority already we saw, that is D7 has highest priority. So as the D7 has the highest priority, even though it is present in that, so D0 will be cancelled. So cancelled means in that place we need to consider it as a don't care, means don't care that we need to have the D7 output, that is 1 1 1 in that first only. Not only 2 inputs, suppose if you have multiple inputs, like if you have an example 3 inputs at a time, suppose if you have in the D5 position 1, that is normal position only. So suppose if you have extra 2 inputs in the same line, that is the D1 position and D7 position. So actually if you are thinking that D5 is the correct position, so I will mark that as 101 as ABC. No, it's not true, because you have to check that priority, that D7 has the highest priority. So D7 will be our output, that ABC would be 111, not 101. Because even though that is present in that line only, but the D7 is also the high voltage, so we need to consider the high voltage, that is 111. So as I said, we need to do not consider the two terms, that is d1 and d5. So as in this case we have the d7 has highest. So if d7 is not there, d5 and d1 only is there, then definitely that d5 is our output. So which one is the highest priority, that is our final output. So I hope you are understanding in the 8x3 encoder, priority encoder also. So we understood the basic overview of priority encoder in 8x3. So now let's understand depth. In depth, we have to solve the Boolean algebra and we have to obtain the output expressions of A, B, C, and we have to we need to get the output expression for the V. So V means here valid. We have already discussed. So how the decoders consist the enable line. In this also we should consider that valid line. That is valid means V. So if we consider valid is 0, the remaining all things would be 0. If all things is 0, that is the reason we have constructed the variable v. If all things are 0, that valid would be 0. If valid would be 1 for all the cases. So the valid output would be the d0 to d7 all the sum expressions. So now let's start the Boolean algebra. So this might take some time because this is the Boolean algebra. You need to understand very clearly. So without understanding we cannot do anything here, because so this need some patience. So if you observe the first variable, that is a. So we have already completed the variable output expression for the v, that is the from d0 to d7 sum. So let's start for the variable equation a, b, c. All outputs we will going to obtain in this video only. So as this is the 8x3 priority encoder, for any of the encoder we can find out the output expression, and after finding the output expression we can simply draw the circuit diagram from that. So if you observe a, so a means we have 4 min terms. If you see there, we have in the position m5, m6, m7 and m8 positions we have the means the here naturally we can speak that, so we can say that 4, 5, 6, 7. So if you consider in the fourth position we have the 1 at a d4. So after in the d4 we have another 3 zeros. So we need to consider that 3 zeros also with the help of the indication the not. So if you consider the only single term, that is in the d7 position. So take first individual d7 plus d7 bar d6, that is corresponding to the last but one, that is corresponding to sixth position, that we can say sixth min term. So d7 bar d6 bar d5, that is corresponding to the m5, I can say m5 min term, because one after another 2 zeros. So 2 zeros corresponding to bars and one d5, that is. So likewise we have to take the first output expression of the a. After that we are going to apply the distributive laws and we are going to obtain the simplified version of a. So if you observe there, I have applied the Boolean algebra rules so that I can minimize that output expression. So if you consider the next 3 terms, so if you see there, the d7 bar is common. So take d7 bar common. After taking that, the inside term, if you see, so this is the same format that we have already discussed. Because if you observe inside, we have d6 plus d6 bar, d6 bar. So inside you have to take d6 bar common, and we need a simple. So we can say that is a d6 bar of d5 plus d5 bar plus d4 into d4. So that can be, already we have some distributive law. So whatever may be the thing, you have to remove the bars. So after removing that, so we will see the inside thing first. Let's see the outside thing. So if you consider the d7 plus d7 bar, we need to cancel out the bar. So the d7 remove the d7 bar, remaining thing. So that is a simple trick that I have told you. So as that remove d7 bar and remaining write remaining term as it is. So after writing that, you can see, so inside also we have some common things, that is d6 bar. So take d6 bar common, you have inside one thing. So after you can see d6 plus d6 bar. So this is also same format. So cancel out the bar format. So you will left with inside bracket terms. So this is the thing that final thing that I am saying about. So you can remember, or you can go through the Boolean algebra formulas, or you can use the K-map for the simplification. K-map is very easy that I can say. So for the grouping and minimization, and you can observe there d7 plus d6 plus d5 plus d4. So this is the final output expression for A. In the same format, we are also going to obtain the output expression for B. So if you observe the min terms corresponding to the B, so that is in the M3, M4, M6 and M7. So we need to, as we are considering the min terms, we should also consider the after term also. So the zeros will be represented corresponding to their bars in the SOP format. After writing 4 min terms as a sum, you can observe, so this is also for, the same format that we already discussed 2 times, that is d7 plus d7 bar into x. So we can simply cut out the d7 bar and remaining we can write simple remaining thing, that b is equals to d7 plus x. That is the simple trick that I have told you up to now. So D7 plus remaining X. So what is X? So cancel out all the D7 bars in the remaining terms. So that is our X. So after doing that, we inside that we have another D6 bar. So takes D6 bar common. So we can see observe that D6 plus D6 bar again the same format. So you have to cancel out the D6 bar. So cancel out that. So after that you can also observe that D5 bar is common. So take out that and cancel out that. Or remaining, or you can remove or you can stay like that. So that is our final output expression for B. And last and final most important thing in this is, so we have already discussed the output expression for V, A, B. So we need also to complete the C. So as you're seeing that the output expression corresponding to 4 min terms according from the C. So you can observe that is in the M2 position, M4 position, M5 position and M7 positions. So corresponding to that you have to write that. So you can see in the next 3 terms you are going to take the D7 bar common. So cancel out the D7 bar. So in all 3 terms. So that is our final output expression, means the D7 plus remaining thing without D7 bar. So after that you can also see the D6 bar common. So take that and cancel out. So inside that we have also the D5 bar common. Take out that and cancel out the D5 bar. So the remaining thing is our final output expression in C. So I hope you understood all the 4 variables. So basically the V is not a variable because that simple sum that is. So A, B, C is the main output expressions for the 8x3 priority encoder. So I hope you should know the basic logic or how the priority encoder selects, or if 2 inputs are sent at a time or 2 inputs are high at a time, which one should be selected. The highest priority should be selected first. So that is the main thing. If you know this logic output expressions also, it's a very good thing. So I hope you understood these things. So finally, thanks for watching up to now.